Hello and welcome guys to Leet Logics. Today we'll be going to discuss the daily leet code problems. So today's daily leet code problem is the longest string chain. So in this longest string chain, what we have to do is that we have to return the length of the longest possible word chain with the chosen word of this. So I will giving you something about the question. We have to give the longest chain such that each word is a predecessor of the next coming word. Well, now what is a predecessor? A word A is a predecessor of word B. If we can insert exactly one letter in word A and without changing the order of the characters, it is equal to the word 2. Like for example, in ABC, we can insert A in between B and C, so it will become ABAC. Thus, ABC is a predecessor of ABAC. While in case of CBA, it is not the predecessor of BCAD because the relative order of the letters is being changed. So we have to return the length of maximum possible word chain. So you can see the words are A, B, BA, BCA, BDA. So what we can do is that we can start from the word and we can start making all the valid predecessors from the word by deleting one character at a time, and thus we can find the maximum length of the word. For this, we can use something like a DP. You can also use memoization for that, but I have used a DP. The time complexity for the DP will be n log n plus n into m raised to the power 2. So coming to the solution, this is the solution. Now you can see first of all the first step is sorting the words array by the length. Like we want the length uh, to be the smallest while iterating. The next we have a map with a string and integer as key as the value pairs. This is basically a DP or a hash map to store the word to length relationships. The next is the max path. We have set the max path to 1 because we wanted to initialize the maximum path length to 1, that is single word. Now what we will do is that we'll iterate through the words given in the words array, and then we'll take each word at a time and iterate because we are iterating for the words. Therefore, we have kept a current length equal to 1, and we have kept a string builder because we want to delete from the string. We want to delete one character from the string. So you can take a character array or you can take a string builder. It is anyways the same. I mean, both will work here. Then the next step will be that we have to iterate through each character of the word. We have to iterate through each character and delete each character one by one. And you have to also store the previous word at the same time. And thus the the words which will be found by deleting one character will definitely be the predecessor of the original word. Therefore, we'll keep the current length. We'll update the current length using dynamic programming. The next step will be that we can update the current word length using dynamic programming, which is this one, and then we'll insert the the character which we deleted. We'll insert back into the string because we want to restore the original word and we don't want to disturb the words. And then what we'll do, the next step, then we'll store the current word and calculated length along with in the DP. That's why we have put in the DP word and current length. And the next step will be updating the maximum path length because we may have got the maximum path length, so thus we need to update it. Therefore, we update the max path length to max length or current length, whichever is the greatest. That will be updated to max path length, and thus we will return the max path. Let me run this for you. This runs. Accepted. You can see. So if we talk about the time complexity is I told you n log n plus n into m raised to the power 2. The n log n is because of the sorting, and for this it is n into m raised to the power 2 because we are deleting each character one at a time, and the space complexity is O of n because we are using a DP if you don't count the original array as space. So only O of n, otherwise it will be O of 2n if you count the words array also. So this was the solution for today's question. Please give it a like and subscribe the channel for daily lead word problems. You will get the problem solutions daily. Thank you.